Section 12.2 is multiplication and division with rational numbers. I emphasized in the last lecture that restrictions were going to be a very important part of this chapter and this course. So as you go through and you do the multiplication and division with rational numbers, the very first step you need to do is figure out what your restrictions are. Remember, you cannot divide by 0. If you have a variable in the denominator, you will have restrictions. Always find your restrictions before you simplify. So this needs to be the very first step. You don't want to factor and divide things out. You want to take your original problem and determine what your restrictions are based on the original problem. So the steps for doing that are to step 1, factor the denominators. Step 2, set each factor equal to 0 and solve. Step 3, these are your restrictions. The solutions that you have from step 2 are the restrictions that you have on your rational expressions. The reason it says in step 1, factor the denominators, is because you're going to have more than one rational expression here. We're going to be multiplying or dividing two rational numbers or rational expressions together. Let's talk now about multiplication. The steps for multiplication include step 1, factor anything that can be factored. That means factor your numerator, factor your denominator, every single rational expression or every single fraction. You need to factor the numerator and the denominator. Step 2, find any restrictions. You can go back up and look and see what those restriction steps are, but find those restrictions. Every denominator, once it's factored, set those factors equal to 0 and solve and find all of your restrictions. Step 3, rewrite your problem so it has only one numerator and one denominator. Do not multiply any polynomials in your numerator and denominator. Leave them factored. Some people can skip this step if they are able to simplify diagonally, and I'll talk about that more when we go through and do some examples. And to put those two things as one numerator, you're just combining all of those products together. You're just keeping all of those products there and putting them in one numerator and one denominator. Step 4, once you have one fraction, you're going to divide out any common factors that you have in the numerator and the denominator. The steps for division are very similar. Very similar, you're going to see that. Your first step is factor anything that can be factored. Numerator, denominator, every single fraction you need to factor if it's possible. Step 2, find those restrictions. You need to do that early. That needs to be done before you do any simplifying. So find any restrictions by setting every single factor that's in a denominator equal to 0. Step 3, we don't like to divide with fractions, so we prefer to multiply. So we're going to use one of those rules that I showed you in the last lecture, and instead of dividing, we're going to turn that problem into multiplication by multiplying by the reciprocal. So instead of dividing by whatever that fraction happens to be, you're going to multiply by the reciprocal, which means you're going to flip the numerator and the denominator on your second rational expression. Step 4, you're going to rewrite your problem so it has only one numerator and one denominator. Again, do not multiply any polynomials in your numerator and denominator. Leave them factored. You don't want to multiply it back out so you have x squared plus 3x plus 12. Leave them in factored form. If you are able to simplify diagonally, this is a step you can avoid. We'll figure whether you can or not do that when we get to the examples. And then finally, step 5 is divide out any common factors in the numerator and denominator. So the really big difference between multiplying and dividing is that you have to turn your division problem into a multiplication problem. Otherwise, essentially your steps are identical. Jumping into examples now, I went into HAWKS to the practice section and just went to the first problem it gave me. Perform the indicated operation of multiplication or division on the rational expressions and simplify. There's no factoring that needs to be done in this particular problem because I do not have any sum or difference here. I have only things that are being multiplied. So this is going to be a little bit simpler. And here's where I'm going to determine whether you are going to be able to very effectively divide things out diagonally. So when I look at this problem, it's a multiplication problem. You see the multiplication problem here. So you can multiply numerators together and denominators together, or if you're good at reducing diagonally, you can do that. And that's what I'm going to do for this one. This 25 and this 25 are going to divide out to be 1. 4 goes into 8 2 times. Now I am going to rewrite it a little bit as one fraction. I have an s squared times t squared in my numerator, and I have 2t cubed times s in my denominator. So I just multiplied across the numerator and denominator. S squared times t squared. I was left with 2t cubed times s. Now I'm going to simplify what I can here. I can't do anything with the 2, so it's going to stay down there. I don't have any other coefficients or integers in the problem. I have s squared in the numerator, s in the denominator. So I have 2 in the numerator, 1 in the denominator. I have more in the numerator. I have 1 more. I have t squared in the numerator, t cubed in the denominator. Most of my t's are in the denominator. I have 1 more. So my solution is s over 2t. Type that in the box. And I hit the wrong letter. There we go. If you hit the wrong letter when you're trying to type on your keyboard, it'll give you an error and just tell you you didn't enter the right character. All right, got that one right. Let's move to the next one. Once again, I do not have to worry about any factoring because we just have a monomial and a monomial. Perform the indicated operation of multiplication or division on the rational expressions and simplify. We're multiplying again, so I am going to go ahead and try to simplify diagonally again if I can. So 4 goes into 24 6 times. 3 goes into 15 5, goes into there once. Now I'm going to rewrite it. I'm left with 1 times 5, so 5x times x squared is x cubed in my numerator. The denominator, I've got 1 times 6, which is 6. Y squared times y squared is y to the 4th. And I think that's all I really need to do. I have 5 over 6, which can't be reduced. I have all of my x's collected in my numerator, all of my y's collected in my denominator. Five x, using my keypad, to the 3rd. You just arrow out to get out of that exponent. 6y to the 4th. Let's see what the next one brings. Okay, division this time. We still look like not having to do any factoring, but I have division. So I do have to remember that I don't like to divide. I'm going to turn this into a multiplication problem. So x cubed over 24 divided by 8x cubed over 9 is going to become x cubed over 24 times the reciprocal, which is 9 over 8x to the 3rd. And now I will see what I can do to simplify diagonally. 3 goes into 9 3 times. It goes into 24 8. I have an x cubed here and an x cubed here. So I think that's all the simplifying I can do. I have this is 1. When you cross everything out, that's a 1 that's left because you're dividing out to be 1. 1 times 3 in my numerator. 8 times 8 is 64. So I believe my solution is 3 over 64. All right. Let's see what the next one gives me. All right, let's just jump right into a problem that's going to take a lot of factoring. So perform the indicated operation of multiplication or division and simplify. We have y squared plus 4y plus 4 over 5y squared plus 11y plus 2 multiplied times 5y squared minus 24y minus 5 over y plus 2. Let's start factoring. Y squared plus 4y plus 4. I'm looking for two factors of 4 that when I add them together give me 4. So plus 2 and plus 2. 5y squared plus 11y plus 10. That's going to be a little bit harder to do because my leading coefficient isn't 1. I'm going to have to use the AC method. So 5 times 2. I'm looking for two factors of 10 that add to give me 11, which is 10 times 1. So remember 5y squared plus 10y plus y plus 2. Greatest common factor between the first two is 5y, which leaves me with y plus 2. Greatest common factor with the last two is 1, which leaves me with y plus 2. So when I factor this, it's y plus 2 times 5y plus 1. I'm going to rewrite this down here and hope I can get the other one next to it. When we factor the right fraction, AC again, 5 times negative 5, I'm looking for two factors of negative 25 that when I add them together give me negative 24. So that's negative 25 and a positive 1. So 5y squared minus 25y plus y minus 5. Greatest common factor on the first two is 5y, which leaves me with y minus 5. Greatest common factor on the second two is 1, which leaves me with y minus 5, and I run out of space. That numerator for this one becomes 5y plus 1 times y minus 5, and then y plus 2. So here's where we can either put these as one big fraction or we can see if we can simplify without it. And I'm going to go ahead and try to simplify without it. So I have a y plus 2 there and a y plus 2 there. Those divide out, become 1. I have a y plus 2 here and a y plus 2 here. Those divide out and become 1. I have a 5y plus 1 and a 5y plus 1. Those divide out and become 1. And it looks like all I'm left with is y minus 5. So when you're simplifying like that, you can simplify top to bottom and diagonally top to bottom. You can't simplify two things that are in the same location. So you can't simplify two things in your numerator and two things in your denominator. You have to be simplifying one piece from your numerator and one piece from your denominator. I'm going to type what I believe is my solution into the box and see what they tell me. Green bar. Gotta love the green bar. That one was a little more complicated. Let's see what the next one is. Very similar, only this time I have y squared plus 4y over 4, y squared plus 4y plus 4 over 5y squared plus 11y plus 2 divided by y plus 2 over 5y squared minus 24y minus 5. So once again, that first numerator is not too bad to try to factor, because 2 factors of 4 that add to 4, y plus 2, y plus 2. This one, I'm looking for 2 factors of 10 that add to give me 11. So that's going to be 5y squared plus 10y plus y plus 2. Take out a 5y, gives me y plus 2. Factor out a 1, y plus 2. So now I have y plus 2 times 5y plus 1. I'll try to write it here. Now I'm flipping these because I'm turning that into a multiplication problem. So this was my numerator. It's now going to become my denominator. I'm going to go ahead and put that there because it's not going to take me any work. And let's figure out what my factored form here is. Negative 25 adds to negative 24. So 5y squared minus 25y plus y minus 5. 5y is the greatest common factor at the beginning. Leaves me with y minus 5. I can take out a 1 in the second two, which leaves me with y minus 5. So I have y minus 5 times 5y plus 1. And now I can go in here and start crossing some things out, hopefully. So y plus 2, y plus 2, y plus 2, y plus 2, 5y plus 1, 5y plus 1, leaves me with y minus 5. I'm just going to erase in the box because I sometimes have a hard time remembering what my solution was. Y minus 5. All right, this one is another division problem. This time, notice something there. We have something we haven't seen for a long time. Not seen in this class. Would have been a class before now. We have x squared minus 9 over 24 divided by x plus 3, the quantity squared, divided by 4. So this means x plus 3 times x plus 3. The nice thing is it's already factored. I don't have to worry about that. It looks like the only one I'm going to have to factor is this one, x squared minus 9. So x squared minus 9 factors into x minus 3, x plus 3, all over 24. And remember, I'm turning this into a multiplication problem. So my 4 was in my denominator. It becomes my numerator. And I'm going to write out the 2 factors that I had from x plus 3, the quantity squared. And now we'll start simplifying. X plus 3, x plus 3. 4 goes into 24 6 times. Looks like I'm left with x minus 3 in the numerator times 6 over x plus, or times, excuse me, 6 times x plus 3 in the denominator. And I can't simplify anything here because I have x minus 3 in the numerator, x plus 3 in the denominator, and I can't separate those. So I'm going to put x minus 3 in my numerator and 6x plus 3 in my denominator. This next problem is a squared minus 25 over 14 times 7 over a plus 5. I love it when I have a difference of squares in my numerator. A plus 5 times a minus 5 over 14 times 7 over, remember a plus 5, the quantity squared is a plus 5 times a plus 5. Clean up that funky looking 7. Start simplifying. A plus 5 over a plus 5 goes. 7 goes into 14 2 times. My numerator, I am left with a minus 5. My denominator, I'm left with 2 times a plus 5. So a minus 5 over 2 times a plus 5. This is going to be my last example. 4a squared plus 3a minus 10 over a divided by a squared plus 7a plus 10 over ab. I'm going to have to factor that numerator. 4 times negative 10, 2 factors of negative 40 that when I add them together, I get 3. Negative 1 times 40, negative 2 times 10. How about negative 2 times 20? Negative 4 times 10. Negative 5 times 8. And that's the combination that I need. Negative 5 times 8 gives me 3. So we'll have 4a squared minus 5a plus 8a minus 10. Greatest common factor between the first two is an a, leaving me with 4a minus 5. Greatest common factor between the next two, between 8a and 10, is 2, which leaves me 4a minus 5. So that factors into 4a minus 5 times a plus 2. And that's over a. I'm flipping these because it's a division problem, so this ab now becomes my numerator. And here I'm looking for 2 factors of 10 that add to 7. So that's a plus 5 times a plus 2. And we'll start simplifying. A plus 2 over a plus 2. That a can divide out with that a. I think that's all. So in the numerator, I'm left with b times 4a minus 5. And in the denominator, I'm left with a plus 5. Clear out the box. And type in my solution. B over, oh wait, sorry, go back up. B times 4a minus 5 over a plus 5. Green, all right. Sometimes I get a little nervous. I don't know, maybe you do too. That is going to be the last example I want to do, but let's go ahead and but scroll through and see what others there are in case there's something that comes up that I'm not expecting. There's a lot of factoring to that one, but still the same thing. We just need to factor. Again, still some factoring, but just a division problem. Same situation, division problem, but factoring. Multiplication, and you have to factor. That one doesn't require a lot of factoring, but same type of a problem. That one's similar to what we did at the beginning. Same. Same. I think we've covered every type of problem that is going to be encountered. That will conclude the lecture for section 12.2.